In section 5.1, you're going to be evaluating, you've known how to evaluate powers of exponents, and so we're going to be reviewing that, and you're going to look at multiplying and dividing and simplifying monomials and expressions involving powers. So your new vocabulary is to simplify, which isn't actually new, you've done that lots of times, and the degree of a polynomial. So here's your properties of exponents that all of you had in Algebra 1, and you may need to take some time to look at these before we continue on, but I'm not going to take time to go through each one of these. We're going to be using them throughout the lesson, so make sure that you make yourself familiar with all of these, because they are going to come up now. So simplifying monomials, there are no powers of powers, and each base appears exactly once. All fractions are in simplest form, and there are no negative exponents when a monomial is completely simplified. So in this case, we're going to, let's turn this into a fraction because we have negative exponents, and so we're going to take the negative exponent with this and the negative exponent with this. That negative exponent causes it to move from the numerator to the denominator or the denominator to the numerator in order to make that exponent positive. So we're going to rewrite this as a squared b to the fourth. That's not going to move. And now it's going to be over a to the negative third a to the third c to the first. And now we see that we can actually simplify. We don't have any b's or c's that we can combine, but we do have these. And so if we think about how many a's would cancel out, two a's would cancel out, and there's going to be an extra a in the denominator. So it ended up being b to the fourth over a times c. And that would be simplified completely. We don't have any negative exponents. We don't have any bases in both the numerator and denominator. And so this is done. Determine whether c to the fourth minus 4 times the square root of c plus 18 is a polynomial. And if it is a polynomial, state the degree. Well, for it to be a polynomial, we can't have negative exponents and we can't have fractional exponents. And technically, if I rewrite 4 times the square root of c, that's c to the 1/2 plus 18. So this is not a polynomial because we have a fractional exponent. And for the next one, is this a polynomial? Well, we don't have any fractional exponents and we don't have any negative exponents, and so it is a polynomial. Now the way you find the degree of it is you have to look at each term and you look at the exponents on the variables. So this monomial term here has a degree of 5, and this monomial here, you have to actually add those exponents together, has a degree of 9. You go with the highest degree monomial in the polynomial, and so this one has a degree of 9. So now we're going to look at simplifying polynomial expressions, which is combining like terms essentially. And so for terms to be like terms, they have to have the exact same variable part with the exact same exponents. So I'm going to rewrite this. I need to distribute that negative sign, so it becomes 2a cubed plus 5a minus 7 minus a cubed plus 3a minus 2. So combining like terms, 2a cubed minus a cubed are like terms, and that ends up with 1a cubed. We have 5a plus 3a, which is going to be plus 8a, and then we have our constants, minus 7 minus 2, which becomes minus 9. Okay, simplify this and align terms vertically and then add. That's another way that you can do this. You can say you have 4x squared minus 9x plus 3, and you can say we're adding to that negative 2x squared minus 5x minus 6. And so you combine these. You have 4x squared plus negative 2x squared, which gives us 2x squared. Negative 9x minus 5x, which gives us negative 14x. And 3 minus 6, which gives us minus 3. So that's another way you can do it if you prefer to align them vertically so that like terms are stacked, or you can do it horizontally like we did in this first problem and just combine like terms from there. So distribute This time is where the properties of exponents are going to come in. So we're going to have negative 4y cubed plus, minus 2y squared. And then negative y times negative 3 is going to be plus 3y. So when you distribute, you have to be sure that and you can always multiply. You don't have to worry about terms being like, but you have to apply the properties of exponents to the variables. Okay, and we're going to skip this problem. So multiplying polynomials. We need to be sure that we distribute everything to everything. So a squared needs to be distributed to the entire a plus 2. 3a needs to be distributed to the entire binomial a plus 2. And minus 4, or negative 4, needs to be distributed to everything. Now I think this is the easiest way to organize and make sure you don't lose any terms. So now when I multiply this out, I have a cubed plus 2a squared plus 3a squared plus 6a minus 4a minus 8. So now I can combine like terms. A cubed, there's not another cubed. We have 2a squared plus 3a squared, which is plus 5a squared. 6a minus 4a is plus 2a, and then minus 8. And that is your final answer. And I believe that's it for section 5.1, so you can go do that worksheet now.